All right, so we have made it to Thursday and we've made it to a new section finally, right? We are in 10.2 factorials and permutations. You can see the definition for permutation. It's arrangement of items, sorry about the typo, of items in a particular order. So you may notice things today that you'll be able to say, oh, we could do that using what we learned Tuesday or Monday or Wednesday. And that's true. We're going to learn another way, and there is some overlap. You could use another method to find the answer to some of these problems, but we are going to be using what we call permutations to find the answers. Now, before we can talk about permutations, we need to talk about factorials. So we'll just do this little bit on factorials, then we'll move to the meat of the lesson. So factorial is a product of n natural numbers, so some natural number. Remember, natural numbers are the counting numbers, so it starts at 1 and goes up from n down to 1. So product means multiplication of whatever that number is from that number down to 1. So let me show you what they mean. Now, when we say factorial, it is represented by this exclamation point. You've probably never seen exclamation points in math, but they do exist. We would read this as 2 factorial. What this means is that we take 2, and its product, so multiply it by every number down to 1. Well, 2 is right next to 1, so it's just 2 times 1. So 2 factorial is 2. All right, 5 factorial starts at 5 and goes down to 1. So it'll go down 4, 3, 2, and 1. And then we multiply. And remember, you can multiply in any order. I'm just going to go left to right. 5 times 4 is 20. 20 times 3 is 60. 60 times 2 is 120. 120 times 1 is 120. So 5 factorial is 120. All right, let's move to 7 factorial. So we know that it's product, so multiplication of 7 or whatever number from 7 down to 1 in this case. So 7 times 6, remember these parentheses are another way to show multiplication, times 5, times 4, times 3, times 2, times 1. And this is where I'd really encourage you. You do not need to do all of the work from the very beginning. Do we know what 5 times 4 times 3 times 2 times 1 is? Yeah, it's 120. So we can just do 7 times 6 times 120. What is 7 times 6? What is 7 times 6? It is 42, right? Okay, and then we have 42 times 120, and we'll probably have to write that one out. Let's go up here to do that. 120 times 42. 2 times 0 is 0. 2 times 2 is 4. 2 times 1 is 2. Leave a space. 4 times 0 is 0. 4 times 2 is 8. 4 times 1 is 4. We add them up. We get 0, 4. 2 and 8 give us 10. Carry the 1, we get 5. And so 7 factorial is 5,040. Do you need to redo these every time? No, you will start to memorize some of them, especially some of the smaller ones, like 3 factorial and 4 factorial. You may start to memorize those. Now, we're ready to talk about permutations. The reason we had to talk about factorials first is because inside of the permutation formula lie factorials, okay? So, first of all, let's break this formula down. The permutation formula, first of all, I want you to look on the left side of the equal sign. We see P just means permutation, okay? Next year, you're going to learn about combination, so the P will be important to differentiate, but just know P means permutation. N represents the number of objects, okay? So I'm just going to draw a little arrow here and fill in number of objects, okay? And R is the number taken at a time, or we could say the number chosen, and I'm going to use that word here, number chosen. And from there, once you've identified what your N and R are, you plug them in over to the formula. So notice we have N minus R, that's in parentheses, so we'll do that first, then factorial, and that's under N factorial. So let's give it a try. I think it'll make more sense, once we try an example. It says use a permutation to find the number of arrangements of 6 books on a shelf. So this is saying if we have 6 books, how many different ways is there to arrange them? Well, let's use our permutation formula. So we have that big P here, capital P. How many objects are there? That's the N. Well, there are 6 books, right? And number chosen. How many of the 6 books are we using? Well, all 6 of them will get a spot, right? So we're going to say 6 books and 6 are chosen, or 6 spots on the shelf. Then, and this part is just to show what we're plugging in for N and R, number and the number chosen or the number taken. And then we plug it over into our formula. So in the numerator, we have N factorial, so that's going to be this number here. So the first one, 6 factorial, and in this case, they're the same. And then down in the denominator, it's N minus R, so 6 minus 6 factorial. All right. Now, let's first find what 6 factorial is, and it'll help to write it out. 6 times 5 times 4 times 3 times 2 times 1. And don't be afraid, and let's get our denominator brought over here. What is 6 minus 6? 0. Now, this is really important. 0 factorial. Most students say, well, that must be 0. And that is not the case. 0 factorial, this is just one thing that we have to memorize. 0 factorial is 1. So if you have 0 factorial, you can change it to just 1. So when your denominator is 1, will that really do anything here? Could we just eliminate the denominator, right? It's still there, but we don't necessarily have to show it. Okay, so again, you should use some of your old work. That's a wise way to do this. If we have 6 times 5 times 4 times 3 times 2 times 1, if we look up above, we know 5 factorial is 120. So we know from here to here is 120, and then we just need to multiply it by 6. So let's do it. 120 times 6. So 6 times 0, 0. 6 times 2 is 12. 6 times 1 plus 1 is 7. There are 720 different arrangements of 6 books on a shelf. Crazy, huh? You're going to have something to do tonight when you go to rearrange your bedroom, right? So notice, number of objects is that represents that N, and number chosen is the R. And we're going to keep using that permutation formula. Here, example 2, use a permutation to find the number of arrangements 5 people can sit in 3 chairs. So let's say we have 5 people, but only 3 chairs. So let's say we could sit 5 students. I'm not going to pick names right now, but we could sit 3 of them in a certain way. And then we could rearrange them. And then we could switch out a student for a different one, right? So we have 5 available people and 3 chairs. How many different ways could we seat them? And the key word is arrangements here. They can be arranged in different orders. So I copied this over here so we still have it. Let's pick what the N and the R is here. So remember, number represents this N. How many people in this case are there? What is the total? And that might be a good word to use there. What is the total number of people here? Well, total number is 5. How many, remember R, if we look back at our notes from the previous page, we said that R was the number chosen. In this problem, how many people are chosen? Well, there's only 3 spots, right? So only 3 will be chosen. So our N is 5 and our R is 3. So now we're going to plug into this right side over here. So N factorial, now 5 is the N, so we're going to go 5 factorial over N minus R factorial. So 5 minus 3 factorial. And I'll show a little more work here. So 5 minus 3 factorial. Okay. Now, from here, let's do a little simplifying. 5 minus 3 is 2. So we have 5 factorial over 2 factorial. That's good. Now, we know from our first problem that 5 factorial is what? 120, right? And we know 2 factorial. Well, 2 factorial is 2 times 1, so it would just be 2. So we get 120 divided by 2 is 60. Now, I do want to show another way that you could simplify this problem. Let's say we came from this step and we brought it down and we were simplifying it. Well, if we expand 5 factorial, that's 5 times 4 times 3 times 2 times 1. And if we bring underneath of it 2 factorial, so 2 times 1, notice, and we'll learn more about this later, we can cancel the 2 and the 1. And what is 5 times 4? Well, it's 20, and 20 times 3 is indeed 60. So using that canceling can really save us time. And next year, you'll have to cancel. The numbers will be too big for you not to cancel. So it could be good practice. When it's all multiplication like this, we can cancel these. 2 divided by 2 just goes to 1. So we can be eliminated there with multiplication. All right, let's move to our final example. Find the number of ways 4 pictures can be arranged on a wall. Okay, so we have 4 pictures lined up on a wall. So this is what I mean when I say 4 pictures arranged on a wall. We want to know how many different ways we could arrange them. So let's say we have a picture of mom and dad, picture of the dog, picture of brother, picture of me, right? So we could rearrange them. So we have mom and dad here, we have the dog here, we have me here, we have my brother over here, right? So we could rearrange them several different ways. We want to know how many different ways could we rearrange them. So again, we're going to pick the N and we are going to pick the R. How many number, remember, is the total number? How many total do we have here? Well, we have a total of 4 pictures. How many are chosen? How many of these pictures get to be involved? Well, we're going to hang all of them, right? So all 4 of them are going to be chosen. We're going to use all 4 here. So we could rewrite that like this. That's what that permutation would look like. From there, we can plug into our formula. So in our numerator, we have n factorial. And notice these numbers are the same, so we don't have to think too hard. We're just going to use 4. So 4 factorial over n minus r, so 4 minus 4 factorial. Now we're going to remind ourselves what we learned on our previous page. We'll leave 4 factorial for a second. 4 minus 4 is 0. It's not just 0 though, it's 0 factorial. What is 0 factorial? We just talked about this in a previous example. What is 0 factorial? It is not 0, it is 1, right? So 4 factorial, you might be able to do this in your head, but I'm going to write it out. 4 times 3 times 2 times 1. 4 times, and it's all over 1. And you can show that, remember 0 factorial is 1. You can show this. Do we have to show it? No, right? If you see a number, like let's see you see 60, well that means 60 over 1, but we don't show the denominator. Okay, so coming back to this problem, 4 times 3 is 12, times 2 is 24, times 1 is 24. So we have 24 over 1, or just 24. There are 24 different arrangements of these 4 pictures on the wall. Remember, if you get to a spot where you think, I don't know how to do this, could you come up with a little problem and try arranging them yourself? Yeah, now 24 isn't so bad, but 60, it would take you quite a while to write out 60 different arrangements, and you probably miss one. That's why we are using the permutation method. All right, taking a quick glance at your homework, and it is super small. I don't know why I made it so small. So we'll see if we can see it here. So first few problems, 1, 2, and 3, you're going to find those answers. Just practicing little factorials, okay? And these should go pretty quickly. Then in number 4, it says use a permutation to find the number of ways to arrange 4 textbooks on your shelf. Number 5 says use a permutation to find the number of ways 5 dogs can fill 5 different pens in a dog kennel. And number 6, it should say use a permutation to find the number of ways 8 athletes can be chosen for first, second, and third place. So 3 different places. I'll give you a little hint there. So we have 8 athletes and 3 of them are going to get medals. Now you're not going to say which is going to get first, second, and third. We just want to know how many different ways it could be. So for example, if we have 8 runners, then John, Emma, and Rachel would get first, second, and third. Or maybe Emma, John, and Jim would get first, second, and third. So there are 8 athletes, 3 are chosen for first, second, and third. Think of how we could do that. So this is your homework, and I will see you guys tomorrow.